Okay, now we'll continue the yesterday's class only. Okay, today we need to. I left one more topic in that yesterday's class because you forced me to stop the class there only. That's what I left one topic there. That is the distributed. In the distributed memory system only, ಹುಡುಗಿಯರು ಅಷ್ಟೇ ಮಾತಾಡ್ತಾರೆ, ಹುಡುಗರು ಅಷ್ಟೇ ಮಾತಾಡ್ತಾರೆ ಅಂತ ಮಾಡಿದೆ, ಹುಡುಗಿಯರು ಮಾತಾಡ್ತೀರಿ ಕ್ಲಾಸ್. Okay, in the last class we left the indirect interconnects. Okay, we know we have the two interconnects. Okay, one is what shared memory interconnect, another one is what distributed memory interconnects. In the shared memory interconnects we have seen the so many things as the interconnection with the normal hypercube and interconnection with the switches with the crossbar and all, and even we have seen the advantages, disadvantages and all. Okay, and also hypercube and the ring also. Ring type, and even we have seen the toroidal mesh also. Okay, even we will be covering the same with the distributed memory systems. Distributed memory system we seen the ring, toroidal mesh, and also we have seen the bandwidth, cross-sectional view and all, and also hypercube. We have seen these things. Okay, and also in indirect interconnects. Okay, indirect interconnects. Okay, what is the necessity of having the indirect interconnects? Since means it's the alternate way to the direct interconnects. Okay, it will provide. Okay, it will not give us switches separately. Okay, in the indirect interconnects we'll not get the switches separately, we'll get the switches with the mesh type only. Okay, in the direct interconnects and some others, okay, we have the interconnects switches will be separate. Okay, but here the indirect interconnects we have the switches with the mesh type. Okay, with the some group type. Okay, this one we see in this figure. Okay, this type of figure we have seen yesterday. Okay, this is what a switching network. Okay, switching network. Okay, we have the in what one switching network. Okay, this can have the many more switches in the in network. Okay, this switch can have the in this indirect interconnects we have the okay, collection of processors. Okay, collection of processors. Okay, these processors are connected to each other with the help of the unidirectional link. Okay, unidirectional link, unidirectional link. Okay, unidirectional links. These switches are connected to one another with the unidirectional links. Okay, these are the switches. Okay, these are unidirectional link. Okay, this processor can have the two links. One is what incoming in interconnect link, another one is the outgoing link. Okay, this is the incoming interconnect link, another one is the outgoing link. Okay, this is the incoming link, this is the outgoing link, this is the incoming link, outgoing link. Okay, how many processors are there? P1, P2, P3. Okay, PN type. Okay, this is the so many processors are connected, collection of processors are connected with the help of the switching network through the links. Okay, each and every processor will have the two links. One is what incoming link, another one is the outgoing link. Okay, okay, incoming link, outgoing link. Okay, there are a number of switches, processors. These are all connected to switching network. With this one we call as the a generic indirect network. This figure is the general type. Okay, generic indirect network. Okay, generic indirect network. Okay, there are two examples for the indirect interconnect network. One is what crossbar, another is the omega network. Okay, crossbar and omega network. Okay, these are the two examples for the indirect networks. Okay, as we already seen the in the shared memory system. Okay, shared memory systems. Okay, we have connected the memories and processors. Okay, one another with the help of the what here the with the help of what switch? Switch. Okay, switch. These are all what called we call the switch. Okay. Okay. These switches are unidirectional. Okay. Here also these switches are unidirectional only. Okay. These are the These are the memories. Okay. These are the memories and processors. Okay. These memories and processors are connected to each other with the help of the what here the switches. Okay, these are all what we call the these are the bidirectional links. Okay, these are all what here the bidirectional links. Okay, whenever we want to communicate with the processor and memory, we can switch. Okay, where we can get the path is very commonly we can communicate with the processor 1 to memory 4 also with the small path. These are whatever the links are here, whatever the links are here, these are all what here the bidirectional. Okay, these are all bidirectional. Okay, these are all bidirectional, but in the indirect interconnect networks, the links are here what here the unidirectional. Okay, these are all the unidirectional links. Okay, these are all unidirectional links. Okay, in the crossbar. Okay, in the crossbar we have seen. Okay, this is the crossbar for the shared memory system. Okay, we have seen in the last class. Okay, but the crossbar for the crossbar switch for the indirect interconnect networks, we'll see that one, how it is to be connected. The same year. Okay, but there I was using the links with the bidirectional. Okay, links with the bidirectional, whatever whichever we want to communicate to the processor to memory, I can easily communicate in the shared memory system. But in the indirect interconnect network, same figure, but the unidirectional links I am using here. Okay, just I'm putting all together same as it is. How many switches here? 16 switches I am using. Okay, and also processors are how many? 4. 4. Okay, this I will be showing here what unidirectional. Okay, unidirectionals. Okay, these are the left side to right side. Okay, sorry. Okay, these are all unidirectional one, and also we have the scene. Okay, then we need to connect to each other. Okay, how to connect the okay, we already seen in the indirect interconnects. Okay, usually we'll be taking switch back to the. Okay, usually processor will have the two links. One is what incoming link, and other is what outgoing link. So I'm getting the unidirectional link here. Also same thing here. That figure only I modified here. Okay, there I use the memories, but here I'm not using the memories. Only processor I'm linking to the switching network. Okay, switching network without any memory. Okay, that's it. Okay, main difference is here only that one only. Only unidirectional, incoming link, outgoing link. Okay. Okay, incoming link, outgoing link. Okay, And also I told you that these are all going back. Even you can connect, communicate to the processor P1 to the, and also we can switch to the another processor also with the, these are the unidirectional, okay? These are the unidirectional. Upper side, you should have to show it, okay? These are the unidirectional. Hmm? Okay, this is the crossbar interconnect for the distributed memory. Okay, distributed memory. Okay, this is the main figure for the crossbar interconnect for the distributed memory. Just to copy this figure. Okay, I already told you that there are two examples for this one. Okay, distributed memory in the indirect interconnects. One is what, crossbar, another is the omega network. Okay, so till now we have whatever is seen, this one is the crossbar switch. Okay, crossbar indirect interconnects with the distributed memory. Now we'll go to the another example. That is the first example is what, for indirect interconnect is what, crossbar switch. Okay, crossbar. Till now you see in the crossbar. Next we'll switch to the another one, that is the omega network. Omega network. Okay, here I am using the 8 processors here. 8 processors here. Okay, connecting to the switches here also. Okay, among the two processors I have the one switch. Among the two processors I have the one switch. Among the two processors I have the one switch. Among the two processors I have the one switch. Okay, I will explain this one just to copy this figure. Okay, I hope you all copied this much. Okay, I have the two links here connecting to the one processor, another to the another processor. Okay, one more is there. Here I have the two links here connecting to the processor P3. Okay, processor P3, and also this link is to be connected to the through the switch with the help of the another link, that was the processor P2. Okay, and similarly I could be connecting the these two also here with the help of the two switches here. I will be connected the one switch to the two processors having the two links here, and also this switch to be used to connect to the processor, connect to the processor. I made it mistake here, sorry. Processor P1, processor P2, processor P3, processor P4. Okay, and also processor P6. Okay, okay, each and every switch, okay, each and every processor will have their own link here, but the one switch can provide the two links here, so that by that one switch I can provide the two links that can connect to the two processor here. Huh? So I have the four links, four switches that can be connected to the 8 processor, okay, separately. And also I already told you that this is the omega network, okay. Okay, these processors can communicate to the another switch. That's when comes the, we can make it just to go through the whatever I am drawing the figure, just to see that. Otherwise you can draw it of your own. Okay, I connected to the this processor to the inner side of switches here, inner side of switches. Okay, I am making the one unidirectional here. Just to look here, last one switches, make it. I made it. Okay, okay. I made it like that. Okay, and even I already told that. Okay, one switch can have the two links here. One switch can have the two links, so that I communicating this switch to the another switch, two links here, so that I can communicate with this switch also here also. Okay, one switch can communicate to the two switches here. One switch can communicate two switches. One switch can communicate to the two switches here. ಇದ್ರದ್ದು ಎರಡು ಅದುವ ಇದ್ರದ್ದು ಎರಡು ಅದು. ಓಕೆ, ಇದ್ರದ್ದು ಒಂದಾಗ್ಯದ, ಇದ್ರದ್ದು ಎರಡಾಗುತ್ತೆ. ಓಕೆ, ಇದ್ರದ್ದು ಒಂದಾಗೈತೆ, ಇದ್ರದ್ದು ಎರಡದು. ಓಕೆ, ಎಲ್ಲರದ್ದು ಎರಡೆರಡು ಇರಬೇಕು. ಓಕೆ, now see here, this is the main here. Okay, I'm communicating this link to the switch to the this switch. Okay, I'm communicating this switch, one more switch I'm using here. This switch I'm using here to communicate here. Okay, similarly I can also use this one is to be communicate this figure switch. Another one is what here. Okay, I left it here 2. Okay, I left it the 2. Okay, ಎಲ್ಲಾನು switches ಎರಡೆರಡು ಕಡೆ communicate ಆಗಬೇಕು. Okay, here I have to one connection, another one is here. I have this one is over, another one is here. Okay, I hope you all following this one. This is called as the figure for the omega network. Omega network. Okay, there I have the how many switches there? Around 9 switches here. Okay, 9 switches adava. Okay, if I consider the one switch, okay, if I consider the one switch in the omega network, how it would be connecting each other? Just look at here. Okay, okay. This is the switch in the omega network. This is figure for the switch in the omega network. This is the switch in the omega network here. Okay. If I have the switch here, the what is the switch? I have the two outputs here, two connecting to each other. Okay. This is the input. This is the output. Okay. This is the input. This is the output. Okay. This is the input. Okay. Input link, and this is the output link. Here the switch will have the only two phase. That's nothing but the two connections here. Okay, this is the figure for the omega network. Okay, omega networks. Okay, omega networks usually will not support the simultaneous communications. Okay, usually the crossbar switch. Okay, this is the crossbar switch which provides the communication with the simultaneous. We can communicate over there. Okay, as I already told you that simultaneous communication was happened, but here the simultaneous communication is not possible here mainly. Okay, and even the if you set the okay, this is the mainly 2 by 2 crossbar. This is the figure for the 2 by 2 crossbar, 2 by 2 crossbar. Okay, this is the 2 by 2. We can say the name as the 2 by 2 omega network. Can also be say, we can name it as the 2 by 2 crossbar, 2 by 2 crossbar. Okay, omega network will not support the simultaneous communication. If you want to communicate with the if you want to communicate with the P1, okay, P1 with the P1, sorry, P0, P0, P1, P2, P3, P4, P5, P6, P7. Okay, if you want to communicate the P0, okay, P0 with the P6 is possible. Okay, P6, P6 is possible. Simultaneously, I can't communicate the P1 with the P7. Processor P1 with the processor P1. Here it means what? Here the crossbar switch provides the communication, simultaneous communication. But here the omega networks will not provide the simultaneous communication, because the if you want to communicate with the P0 to P6, okay, simultaneously it cannot communicate to the P1 to P7 at the same time. Okay, this will not provide the simultaneous communication. Omega networks is very less communication, less expensive compared to the crossbars. Okay, this is the main advantage. Okay, crossbars will have the more in cost, but here the omega networks will provide the less expensive. Okay, the omega networks usually the have the how many number of switches here? The okay, 1 by 2 p logarithm of 2 of processors. Okay, okay, how many switches we can have the omega network? 1 by 2 p logarithm of p. P is what here? The processor. If the number of processors, will see the these many processors, if you calculated by the giving the processors with this formula, thereafter we can easily calculate the number of switches here, number of switches here. Okay, number of switches, it's usual total number of usually 2 by 2 crossbar usually have the okay, it's usually total number of you can calculate the 2p logarithm of logarithm of 2, okay, logarithm of 2, okay. This is the usually the omega network, okay. If you use the 2 by 2 crossbars, usually we have the 1 by 2 p of logarithm of 2 p number. While giving the number of processes, we can calculate the number of switches. If you have the omega network, you will have the 2 of p 1 by 1 logarithm of 2 p, okay. If you give the number of processes, we can easily calculate the number of switches. In the examination, they will ask sometimes while giving the number of process, you just to calculate the switches. Okay, if they ask, just to remember this formula. Okay, usually the bisection. Okay, usually we see in the crossbars usually provides the bisection. Okay, but here the bisection is not possible. We have seen in the last class bisection bandwidth and all. Okay, there we have seen in the crossbars, but here the bisection of this omega networks is not possible to get that one. Okay, mainly the want to divide the okay, if you want to connect the what is the necessity of having the crossbars. Okay, crossbars usually bisection ಮಾಡೋದ್ರಿಂದ ಏನು ಯೂಸ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ number of nodes we can number of connections or number of nodes we can reduce. Okay, we can reduce, but here it's not possible to have it. Okay, in the omega network it's not possible to have the that kind of configurations. Okay, by bandwidth. Okay, bisection of this p into p crossbar is a p. Okay, the bisection width of the omega network is p by 2. Okay, p by 2. Bisection of the crossbars is p by 2. P into p is what here the p only for the crossbars, but the bisection for the uh, bisection width for the omega networks is what here the p by 2. Okay, this is the for the crossbars. This is crossbars. This is for the omega networks. Okay, this is the what here the for the bisection width. This is a bisection width. Okay, okay. Okay, we shall move to the next topic. I hope you all followed this. Huh? ಗೊತ್ತಾಯ್ತಾ? Huh? Okay, take some notes. In the distributed memory crossbar links are in the distributed memory crossbar links are unidirectional. Okay, links are unidirectional. Links are unidirectional. Links are unidirectional. Okay, as we noticed that as we noticed that as long as two processors don't attempt to communicate, two processors don't attempt to communicate with the same processor as long as two processors don't attempt to communicate with the same processor, all the processors simultaneously all the processors all the processors can simultaneously communicate another with another processor for the crossbar network for the crossbar. But but in omega network the simultaneous communication cannot occur. The simultaneous communication cannot occur. Omega networks are also called as, next point, omega networks are also called as 2 by 2 crossbar. 2 by 2 ಅಂದ್ರೆ ಹಿಂಗೆ ಬರಿಬಾರ್ದು, 2 ಅಂತ ಬರೀರಿ ಮತ್ತೆ ಅಲ್ಲಿ ಬರ್ತೀನಿ ನೋಡಿ, 2 by 2. Okay, 2 by 2 crossbars. For example, processor, for example, figure 1 in figure 1, processor P0, processor P0, processor P0 sends a message to processor 6. 0 ಇದ್ದದ್ದು ಪ್ರೊಸೆಸರ್ 0 ಇದ್ದದ್ದು P0 ಇದ್ದದ್ದು P6 ಜೊತೆ ಕಮ್ಯುನಿಕೇಟ್ ಮಾಡ್ತದ. ದಟ್ ಸೈಮಲ್ಟೇನಿಯಸ್ಲಿ P1 cannot communicate to the P7. Okay, processor P0 sends a message to the processor 6. Then THN, then processor P1 cannot simultaneously send a message to processor P7. Next point, processor P7. Next point, omega network is less expensive than crossbar. Omega networks are less expensive than crossbar. Than crossbar. Okay. Next point, the omega networks uses. Next point, the omega networks uses 1 by 2. 1 by 2 p of logarithm of 2 p. Omega networks uses 1 by 2 p logarithm of p of 2 by 2 crossbar switches. 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 So it uses a total of 2 of 2p logarithm of 2 of p. Okay, so it uses a total number of switches. So it uses the total number of 2p logarithm of base 2 of p number of switches. Okay, the omega network uses the 1 by 2 logarithm of 2 of the 2 by 2 crossbar switches, so that it uses the total of 2p logarithm of 2 switches, while crossbar uses a p square. Okay, next point, it is difficult to define bisection width for the indirect It is difficult to define bisection width for the indirect networks. Okay, next point. The bisection width of P into P crossbar is P. The bisection width for the P into P crossbar is what here? The P into P crossbar is P. P into P crossbar is what here? The equal to P. But bisection width for the omega network is P by 2. But bisection width for the omega network is P by 2. Okay, I hope you all copied this one. Sorry?
ಹೆಂಗ್ ನಡೆದದ
ನಡೆದದ್ರಿ.
ಅದೇ ಜಾಯ್ನಿಂಗ್ ಕೊಡಕ್ ಬಂದಿದ್ದಾರೆ ಫುಲ್ ಟೈಮ್ ಬಾ ಅಂತ
ಫುಲ್ ಟೈಮ್ ರೀ, ಫುಲ್ ಟೈಮ್ ಬಂದ್ರೆ ಅನುಕೂಲ ಆಗ್ತದೆ. ಇಲ್ಲಿ ಯಾರು ಇಲ್ಲ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಸ್ಯಾಲ್ರಿ ಇನ್ಕ್ರಿಮೆಂಟ್
ಅಷ್ಟೇ. ಮತ್ತು 25 26ಗೆ ತಂದಿಲ್ಲ ಸಭಾ 30 ಕೇಳಿ ಆರಾಮ್